You are watching video on SEE examination preparation grade 10 exam subject science. In this video, we are going to do final revision of chapter acids, bases and salts from chemistry. The topics or the questions mentioned here have been asked in previous board exams. There is a major part in chemistry which requires memorizing. I'll try my best to make such learning easy in this online tutorial. So we are going to revise chapter acids, bases and salts. Question number 1, write down the differences between acids and bases. So while you learn differences, so you have to write definitions and other points in the differences. So you'll be learning definition as well while you learn answer for differences between. So acids and the bases. Point number 1, acids are the substances which give hydrogen ions or the protons when dissolved in water, or it is called aqueous solution. Bases are metallic oxides and hydroxides and give hydroxyl ions or OH minus ions when dissolved in water. So the first points are the definitions of acids and bases. Number Point B2, acids, they are sour in taste and corrosive in nature, whereas bases are bitter in taste and soapy or slippery in touch. Point number 3, under acids, they turn blue litmus paper into red color, whereas bases turn red litmus paper into blue color. So these are the differences between acids and bases. So in these differences, point number 1, these are the definitions of acids and bases. Point number 2, physical properties of acids and bases. Point number C, chemical property of acids and bases. So you can learn these points in this manner. So if you are asked to write physical properties, then you can write for acids, they are sour in taste and corrosive in nature. For bases, they are bitter in taste and soapy in touch. And if question asks you to write chemical property, then you can write about litmus paper. Acids turn blue litmus paper into red color, whereas bases turn red litmus paper into blue color. So these are the answers. Now question number 2, write down the differences between strong acids and weak acids. So usually two points are asked in the examination. So differences between strong acids and weak acids. Strong acids, they give more hydrogen ions when dissolved in water, and weak acids, they give less hydrogen ions when dissolved in water. So strong acids give more amount of hydrogen ions when dissolved in water, whereas weak acids give less amount of hydrogen ions when dissolved in water. So this is for weak acids, this is incomplete ionization, and for strong acids this is complete ionization. Because of complete ionization, more amount of hydrogen ions will be produced in water, whereas in case of weak acids, incomplete ionization, less number of hydrogen ions will be given out in the solution. Now point number 2, in strong acids, most of the mineral acids are strong acids. You have to write most word because few mineral acids are not strong. For example, carbonic acid. That is why you have to use word most. Most of the mineral acids are strong acids, and weak acids, most of the organic acids are weak acids. Okay. So example of strong acid is sulfuric acid, and example of weak acid is citric acid, which is an organic acid. Sulfuric acid is mineral acid or inorganic acid. And these are the answers. Now we'll see the next point, that is give two differences between organic acids and inorganic acids. So very easy points. Organic acids are obtained from living organisms, whereas inorganic acids are obtained from minerals. These are not obtained from plants and animals, minerals. And organic acid, point number 2, they are weak acids. Mostly they are weak acids. Inorganic acids are strong acids. For example, sulfuric acid, nitric acid, hydrochloric acid, the acids which are prepared in laboratory, these are mostly inorganic acids, and these are strong acids. So example of organic acid is acetic acid, and example of inorganic acid is nitric acid. So these are the differences between organic acids and inorganic acids. Now question number 4, define alkali. Define alkali and give reason. All alkalis are bases, but all bases are not alkali? So this is an important question. This is uh, a common question. Okay, so answer: alkalis are the substances which are formed when metallic oxides dissolve in water. Metallic oxides dissolve in, metallic oxide is dissolving in water, and it is forming hydroxide, and hydroxide is called alkali, right? Alkalis are the chemical substances which are formed when metallic oxides dissolve in water. So magnesium oxide is metallic oxide. It is dissolved in water to form magnesium hydroxide. Magnesium hydroxide is an alkali. So alkali are such chemical substances. Now the next part of the question are: all alkalis are bases, but all bases are not alkalis. Give reason. All alkalis are bases. All the alkalis come from base, but all the bases cannot become alkali. So this is the question. You have to explain this point. Metallic oxides dissolve in water to form alkalis, just like this, to form alkalis or hydroxides, right? There are some metallic oxides which do not dissolve in water to form alkalis in this manner. All of them do not dissolve in water in this manner. Example: mercuric oxide, cupric oxide, ferric oxide. Ferric oxide means iron oxide. Okay, so these oxides do not dissolve in water to form hydroxides, right? So therefore, and which do not dissolve in water to form hydroxides, these are only metallic oxides, these are not hydroxides, right? So therefore all alkalis are bases, but all bases are not alkalis. So all alkalis are bases, but all bases are not alkalis. All metal oxides do not dissolve in water to form hydroxides. That is why all metallic bases cannot become alkalis. So this is your answer, question number 4. Now we'll see question number 5. Question number 5 is: define salt. Salt is a compound formed by positive ion of base and negative ion of acid. So this way, sodium chloride is an example of salt. It is made up of Na plus Cl minus ions. Okay, sodium ion, Na plus ion is coming from base. Okay, Cl minus is coming from acid. So salt is a compound which is formed by complete or partial displacement of hydrogen ion by metal ion. This is the other definition of salt. That means complete or partial displacement of hydrogen ion by metal ion. Metal ion come in place of hydrogen. Okay, so metal ion will be there in the salt. Na plus Cl minus. Salt is made up of, first part is metal part, second part is non-metal part. Metal part has come from base, non-metal part has come from acid, right? So anyway, you can write easier definition over here. Salt is a compound formed by positive ion of base, metal part is base, and negative ion of acid. Negative ion has come from acid, Cl minus. So this is the definition of salt. Now next question is: differentiate between normal salt, acidic salt, and basic salt. So sometimes you may get the question like write the differences between normal salt and acidic salt, or write the differences between acidic salt and basic salt. So if you learn all three types of salt together, it will be easier to understand. Normal salt, it is formed when strong acid reacts with a strong base, or weak acid reacts with weak base. Both are weak or both are strong. Strong acid reacts with a strong base, or weak acid reacts with weak base. Okay, in that case normal salt is formed. Sodium chloride, potassium chloride are the examples of normal salt. And let's go to acidic salt. Acidic salt, it is formed when strong acid reacts with weak base. So acid should be strong, base should be weak in order to form acidic salt. For example, copper sulfate. Copper sulfate is acidic salt because copper sulfate is made by the reaction between strong acid. Strong acid is sulfuric acid in this case, and weak base is copper oxide. Copper oxide is weak base and sulfuric acid is a strong acid, and reaction between these two has given out copper sulfate, which is acidic salt. Anyway, example of acidic salt is copper sulfate, CuSO. 4, CuSO4. Now the basic salt, it is formed when a strong base reacts with weak acid. A strong base reacts with weak acid, for example potassium carbonate. Potassium carbonate, K2CO3. K2CO3. So this is a basic salt. Yes. And these are the differences between normal salt, acidic salt, and the basic salt. Now we'll go to the next question, that is, name the acid found in each of the given substances. So juice of lemon, citric acid, we know juice of lemon, oranges, etc., citric acid, and vinegar, acetic acid. Vinegar, acetic acid. Vinegar is used in food preparation, in seasoning, okay, making food more tasty. Vinegar is used, and vinegar is actually acetic acid. Acetic acid. And next question is, name any two alkalis that react with the skin. The alkalis like sodium hydroxide and potassium hydroxide react with the skin, means they give skin burn. These bases, sodium hydroxide, potassium hydroxide, cause skin burn. Skin burn. Okay, so they react with the skin. And next question is, name the bases which are used for given activities. So these are to purify sugar, and to purify petroleum product. To purify sugar, base like calcium oxide is used. Calcium oxide is used, which is quicklime. Calcium oxide is quicklime, and this process is also called carbonation. In carbonation process, calcium oxide is used. And to purify sugar, you have to remember, to purify sugar, calcium oxide is used. Calcium oxide is metallic oxide, it is a base. Okay, and to purify petroleum product, sodium hydroxide is used. Sodium hydroxide is used, and this process is called caustic wash. Anyway, if you remember, that is okay. Otherwise this is the process, just for your understanding. Okay, to purify petroleum product, sodium hydroxide is used. To purify sugar, calcium oxide is used. So these are the uses of bases. If you learn these 2 points, you can write in uses of bases also. Okay, if question asks you to write the 2 uses of bases, you can write this. Okay, so base is used for preparation of soap. You have learned that. Okay, so that is also easy point. Write down a name of alkali which is used to balance the pH of human stomach. Alkali which balances the pH of human stomach is magnesium hydroxide. Magnesium hydroxide, which is also called milk of magnesia. Okay, so acidity of the stomach is treated by using this compound, magnesium hydroxide, which is alkali or the base. Okay, so this is the alkali which is used to balance the pH of human stomach, right? Acidity of the stomach is treated. Now the next question is question number 11. Now question number 11 is this one. Name the acid found in each of the given substances. Sour milk and gastric juice. Sour milk contains lactic acid, and gastric juice contains hydrochloric acid. Hydrochloric acid is formed in our stomach, but it is not an organic acid. So this question will be there in the exam. Sometimes it is asked, it is because hydrochloric acid is not organic acid, although it is formed in the stomach of human being, because it does not contain carbon atom in it. Absence of carbon atom. Okay, because of absence of carbon atom, hydrochloric acid cannot be called organic acid. Sodium hydroxide is called a base, but sodium chloride is called salt. Why? So this question, sodium hydroxide is called base because it gives hydroxyl ions when dissolved in water, OH minus ions. The chemical compound which gives OH minus ions in water, when it is dissolved in water, then this is base. Okay, sodium hydroxide gives Na plus OH minus ions. These hydroxyl ions are produced, that is why it is called base. Hydroxides. In base it is hydroxides. Sodium chloride is called a salt because it gives metal and non-metal ions in water. When salt is dissolved in water, salt forms metal ions, non-metal ions. It gives metal ions, non-metal ions. That is why sodium chloride is a salt, because salt is made up of positive ions of metal, negative ions of non-metal. And next question is question number 13. It is dangerous to touch or taste acids. Why? Acids are sour in taste, but all the acids should not be tasted. It is very dangerous because it is dangerous to touch or taste acids because acids are corrosive in nature. They cause wearing of the skin, metal, wood, clothes, etc. Okay, so any kind of surface which they come into contact with, so they wear away, means they acids cause acid burning. Acid burning is caused, means wearing away, thinning away, okay, burning. So because of this reason, acids should not be tasted or they should be touched with bare hands. So this is your answer. Now next question is question number 14. Question number 14 is, write down any three examples of neutralization reaction in our day-to-day life. Okay, so this is also important question. Farmers use quicklime or calcium oxide or quicklime to remove acidity of the soil. Right? If the soil is acidic, then farmers mix calcium oxide or quicklime. Magnesium hydroxide, milk of magnesia, is used as antacid to treat hyperacidity of stomach. Acidity of stomach is treated by using magnesium hydroxide. This is number 2 use. Number 3 use. Ant sting is acidic. When ants or the insects sting us, then there will be burning sensation in the skin. That is because of some kind of acid is injected into our skin, and that is formic acid. Okay, so it is treated by using baking soda and soap, because baking soda and soap both are basic substances. So when acid is treated with base, it gives neutralization effect. No, it normalizes the effect. So that is why basic substances like baking soda or soap, baking soda and sodium bicarbonate, baking soda is, and soap, these are used. The affected part is washed by using soap and applying baking soda. So these are the basic substances. Now next is, these are the uses of neutralization reaction in our day-to-day life. Remember these 3 points, these are important. Now sulfuric acid is called as king of chemicals because sulfuric acid is used widely in industries and laboratories. Chemical laboratories. Wide use of sulfuric acid in industries and laboratories. Because of that reason, sulfuric acid is called king of chemicals. Next question is question number 16. Give an application of each of the following compounds: calcium sulfate, sodium hydroxide, sulfuric acid. Calcium sulfate, gypsum. It is used for plastering fractured bones of the body. For plastering fractured bones, the white material is applied on the broken bone, okay, while plastering, and that is calcium sulfate. Sodium hydroxide is used for making soap. Sodium hydroxide is an important ingredient in making soap. You have learned this, sodium hydroxide, or sometimes potassium hydroxide is also used for soft kind of soap. Sulfuric acid is widely used in laboratories and industries, or it is used for making chemical fertilizers. Sulfuric acid is used for making chemical fertilizers. So you can remember these uses of these substances. Now we'll see the next question, that is question number 17. Question number 17. How is salt prepared? Mention any two methods. Two methods are asked for salt preparation. Very easy points are there. By direct combination of metals and non-metals. Sodium plus chlorine, sodium chloride. Look at this equation. It is very easy equation. Sodium 2Na plus Cl2, 2NaCl. by direct combination of metals with non-metals. And number 2 is by neutralization reaction of acid and base. When acid reacts with base, it forms salt and water. They form salt and water. So this is very common chemical equation. If you learn this equation, then you can write this equation to answer other type of questions also. For example, give an example of neutralization reaction. Sodium hydroxide is a base, hydrochloric acid, these two react with each other to form NaCl plus H2O. So these are the two methods by which salt can be prepared. Okay, now question number 18. A compound gives hydrogen and chlorine, hydrogen and chlorine ions in the solution state. A compound gives hydrogen and chlorine ions in the solution state. Okay, write down the name and molecular formula of the compound. Hydrogen ion, chlorine ion. Hydrogen ion, chlorine ions are produced in the aqueous solution. So the compound is hydrochloric acid, HCl. Question number 2. What would be the color of methyl orange when it is treated with above compound? Methyl orange is treated with hydrochloric acid. When acid is treated with methyl orange is an indicator. It changes into red color. Okay, it changes into red color. Light yellow color of methyl orange changes into red color. Now, next question is write down the name of salt formed by chemical reaction of above compound with zinc. Write chemical equation. So, hydrochloric acid reacts with zinc to form salt and hydrogen. So, if you learn this equation, you can write this in answering question like how is salt prepared. This is also one method of producing salt. No? So, Zn plus 2HCl, ZnCl2 plus H2. So, you have to remember this chemical equation. Zinc reacts with hydrochloric acid to form zinc chloride and hydrogen. So these are the questions. Now in this chapter, if you are asked to write two uses of acids, then what will you write? Acids are used to make chemical fertilizers. Acid is used to make soda water, carbonic acid, which is an edible acid. Acids are edible. For example, citric acid in lemon, oranges, etc. Lactic acid in milk or the curd. And acetic acid in vinegar. So these are the uses of acid. And if you are asked to write the uses of bases, then you can write base is used for making soap, sodium hydroxide. Base is used for treating hyperacidity of the stomach, magnesium hydroxide. So these are the uses of bases. Okay, base is used for neutralizing acidity of the soil, calcium oxide. So these are the uses you can remember easily. If you are asked to write uses of salt, then salt is used in our food. It is so simple, it is so easy. And salt is used in chemical laboratories. Different kinds of salts are used in chemical laboratories. For example, copper sulfate is used in laboratory. Okay, so these are the uses of the acids, bases and salt. So with this we have finished the revision of acids, bases and salt. We'll do more important topics and the chapters in next video.